already explained what a polymer was in a previous lesson, so here it is. Okay guys, you remember from our last lesson, which was grade 10 science first unit, we talked about bonding of molecules and so on. We're going to expand on that technique right now and talk about how molecules can bond and how the different properties are affected by these sorts of things, especially when they interact with other kinds of molecules. So what I'm going to show you here is, this is a real molecule that's been blown up to about 10 trillion times its normal size. As a teacher, of course, I can see the molecules, but you guys aren't at that level yet. Yes, Christine?
What's a trillion?
A trillion is 1 times 10 to the E. Anybody know?
12.
Correct. Very good. Mateo gets a point. Point. If we take this molecule and combine it with a lot of other ones like it, we end up with something like this, where we have a much bigger molecule. And the name of this molecule construct is called a polymer. So if we take a look back at your Greek, poly means many, and mer comes from Greek, which means to share. You don't have to remember that. I find it easier for people to remember the concept if you understand the origin of the word. So we have. What the hell are you looking at me for? Read the green screen. A polymer, which is essentially one gigantic molecule, and sometimes that molecule can interact with other molecules, which we'll talk about in a second. So there's our polymer, and it's made up of many of the identical unit here, zillions and zillions of them. Now, come and take a close look here at this pile of powder, and just estimate in your mind what you think the volume is. I mean, you don't have to get it exact. The idea is that it's not very much. So you could say, say 5 cc's, 10 cc's, or something like that. Now, each of these grains here, if you sort of just take a look there, looks like a grain of sand. You notice how each little blob is extremely small, barely large enough to be able to see. Now, I'm going to put this in a dry glass here, using the, I'm sorry, question?
What is the wax?
We're going to talk about that too. This is a special molecule called a polymer. I'm going to use a high-tech digital method, which are my digits, and put them in the dry glass here. So if we take a look again, if you can sort of see against my dark shirt, you can see that the pile of powder, in terms of volume, is not particularly big. Bear that in mind when we do what we do next. Now, we have these little polymer molecules represented by this, and we're going to add water to them. We're going to start to interact. Now, if we add the molecules like this, it doesn't look as if it gets very much bigger, does it? No. We'll keep our molecule model here and start adding the water. Oh, added too much water there, but we're just going to let that sit for a second there now. What happens normally when you take a white powder like that, like say salt or something that's polar, remember we talked about polar compounds, and mix it in water?
Dissolves?
It dissolves, yes. So do we end up with 1 phase, 2 phases? That's right, because it all goes together. Now, if you take a close look here, so I put a bit too much water, and you notice that unlike a one-phase liquid, it's actually started to develop the properties of what my distinguished colleague, Ms. Stupich, is going to teach you about with states of matter. You notice that it's actually, okay, I'm not quite courageous enough to try this, but okay, take a look at that. The liquid and the powder have formed something completely different. What do we have here?
A gel.
Correct, yes, a gel, yeah. The polymer, which is the blue original material here mixed in with a different compound, which is water. So we have 2 different compounds, and they've bonded together to form something completely different. It has taken on a different property. We've gone to something which is more like what, a gas? Or
more like a
solid.
Solid, yeah. More like a solid, but a semi-solid, so Mateo is actually completely right. You can take the rest of the class off, Mateo, you're good.
Contact lens.
That's very good. Now, we could actually reverse this process by mixing in salt. Unfortunately, I didn't bring the salt with me. So the idea behind this kind of reaction is that we have many molecules. If I just represent that with a little m, so they join together like this, like our little Lego model. The idea is that we can also break apart those unions so that we go back to the original separate molecules, or monomers. And in that case, mono, notice the root word, mono as opposed to poly. What does mono mean? And I don't want to hear about kissing sicknesses. Jared? One, correct. Yes, mono means one. So from many back to one. If your teacher was a little bit better organized, he would have had the salt, because with salt we can actually reverse the process. How are we doing for time? Is it time for a French yet? We're okay? All right, now, do we have any questions about this basic? Yes, Christina?
Can I touch it?
I'm sorry?
Can I touch it?
Yes, you can. Yeah, I won't touch it. Just don't lick it or swallow it. Yes, Jerry.
So if we added salt, the yellow pieces would break off of that, essentially?
Yes, that's correct, yes. So essentially what would happen is the salt would displace the bond you see between the different kinds of molecules here. So one represents our original monomer, and I think Christina's question, or was it Alexis? Somebody asked what it is. The technical term for this compound is sodium polyacrylate. We don't have to worry about that till you get to grade 11 or 12 next year. But the idea is you have two different ones here, and if you have a different kind of molecule or atom which preferentially binds, it will cause these other ones to break off. So it's like there's competition. You can go ahead and take a look at that and squish it. Sometimes we use this to make instant snow.
That's what I thought.
One last question before the bell goes. Can anyone think of a real-life application for this kind of transformation between bonding and properties? How might this be useful in real life? Something that, for example, absorbs a lot of liquid but doesn't end up being wet. Is there a potential use you can think of for this kind of element? Jared?
You could put salt onto snow and that breaks it up into
Very good.
liquid
Yes, that's
again.
one way. Haven't heard from you, Corey. Any ideas? How would this relate to real life?
Well, if you had like an oil spill or something?
Yes, correct. Yes. If you want to sop up something that's really liquidy so that it can bond together and form one big blob. Now instead of all these liquid molecules which are everywhere, you can just pick up your blob, just as you guys are doing, and throw it off. In fact, the most common use in real life for sodium polyacrylate is in diapers. So if any of you guys that's right. By volume, this particular compound can actually expand up to about 200 times before it becomes supersaturated and then there's no more room for the liquid. I will not expect you guys to memorize the compound equation for this, but if you look in your textbook on page 2, you can read a little bit more about this, and next class will expand upon that. Thank you.
Stay tuned for the next video.